Last time we met, we talked about periodic functions, and they were functions that repeated themselves. There's 6 very special periodic functions: sine, cosine, tangent, cosecant, secant, and cotangent. Now we're going to look at these graphs. We're going to be doing them by hand. I'll be using my calculator to help, but I know that a lot of you don't have calculators at home. I'll be posting another video on how to use Desmos to make these graphs. But for this, kind of let me make the tables for you and just follow along. As far as for the note taking, you can either print out the notes or you can write on the note on the PDF using things like Kami, K-A-M-I, lets you write on any PDF and then save your annotations. We'll start with sine. Now, as far as in my calculator, things I have set up. So these are all in radians. So I'm making sure that in my calculator, my mode is in radians. I also went in and did something special. I went into the table setup and set that the independent was going to be ask. So that way I can type in all of these x values, these angles, and it'll give me the sign of each of them. Now I want my table to start at 0, so I'm going to change that to 0. And y equals, I put in sine x. So now I'm going to go to the table. And notice the table's empty because I set it up to ask. So my x value is going to be 0, and the sign of 0 is 0. The next one is pi over 4. So I'm going to type in pi divided by 4. And we know that as square root of 2 over 2 when we're looking at our unit circle. But the square root of 2 over 2 is also 0.707. And so for graphing, we want it to be more exact. We want not more exact, we want the decimal version because it's easier to graph. All right, so the next is pi over 2. And at pi over 2, sine is 1. 3 pi over 4. Oh, it was square root of 2 over 2 as well, so that's 0.707. Now I've got pi, and the sign of pi is 0. So on my unit circle, when we got back, so let's think about the unit circle. Sine were the y values. So here was the 0.10. So sine of 0 is 0 because the y value is 0. When it gets up to here, the sign is 1. And then when it comes back down here, this is -1, 0. So the sign is 0 again. Now as I go around the unit circle, now my y values go negative. So watch what happens when I type in. I'm going to zoom in a little bit onto that camera. So if I put in 5 pi over 4, I get negative 0.707. So on this side, the y values are negative. 3 pi over 2 is -1 because at this point right here, it's 0, -1. And then when I type in 7 pi over 4, I get negative 0.707. And then when I get back to 2 pi, I'm back to 0. And as you go along, you're going to go back around the circle again all the way to 4 pi. So this pattern is going to repeat itself every 2 pi. So I'm going to go ahead and plot these points. I suggest that you pause the video and then while you plot the points, because I might be a little faster than you. And I've got my table set up right above me. So 0 goes to 0, pi over 4 is 0.7, which is approximately there. Then it goes to 1, 0.7, 0, negative 0.7, negative 1, back to 0. This pattern is going to repeat itself. And I'm kind of getting an idea of what this graph is doing. So I'm going to go back over here and hit graph. Now another thing I have set up on mine is I have it set on the zoom for trig. And what it's doing there is it's set up perfectly with pi over 2's and pi over 2 and then 2 pi. So we can see that it's a nice curve and that it repeats itself. And so some of the things we want to document, first of all, I want to document what the domain is. The domain goes on forever, actually, and that's going to be all real numbers, or you can write negative infinity to infinity. The range, well, let's see, the y values are my range, and the lowest it gets is negative 1, the highest is 1, so it's going between negative 1 and 1. Guess what? That's also telling me about my amplitude. My amplitude is 1. It goes 1 high, 1 low, 1 high, 1 low, so forth. The period, how long does it take to repeat itself? Well, the period, so it went up, down, here. Then it starts repeating itself, so it is at 2 pi, from 0 to 2 pi, so 2 pi. So we can copy these over to the front page. So on sine, the domain was negative infinity to infinity. The range was negative 1 to 1. The period was 2 pi. And over here where it says asymptotic behavior, we had no asymptotes. Okay, the next one is going to be cosine. Now the beauty of how I set up my calculator is in my y equals, I'm going to change that to cosine and go back to the table. Now all of those x values are still in there. It just changed the y values now to be the cosine of each of those angles. So cosine of 0 is 1. Cosine of pi over 4 is 0.707. Then it goes to 0. Negative 0.707, negative 1, negative 0.6. So I'm copying these straight from this table. And again, if I go too fast, you can always pause and catch up. I'm going to look at the graph real quick. Oh, it's a nice curvy curve too. And it's repeating itself, going up and down and up and down. So cosine of 0 was 1, pi over 4 was 0.7, pi over 2 was 0, negative 0.7, negative 1, negative 0.7, 0, 0.7, 1, I bet it's going to repeat itself, 0. So we end up with this very similar to sine. It's a wave, but this time instead of starting at the origin, starting at the middle and then going up from there, it's starting at the top of a hill and it's going down and then up and then down and then up. But the domain is also going to be all real numbers, infinity, just like sine was. The range, it's still going between negative 1 and 1. That means my amplitude is 1. The period, it's still going between 0 and 2 pi. So 2 pi is 1 period, and that's 1 trip around the circle, so that also makes sense too. And then it has no asymptotes. So let's copy those over to the front page. Cosine, the domain is negative infinity to infinity, negative 1 to 1, 2 pi, and no asymptotes. The next one we're going to look at is tangent. So again, all I have to do in my calculator is change this to be tangent x and go to the table. Oh, it's giving me some weird stuff here. Get this in focus. So 0 goes to 0, 1, error, negative 1, 0, 1, error, negative 1. I wonder what's happening at each of those places where it says error. Let's look at the graph. Ah, that is a vertical asymptote. That actually means that we were dividing by 0 there. We had an undefined. That's why we're getting an error in the calculator, is that I was dividing by 0. And so I get a vertical asymptote there, and then another one there. Interesting. Okay, so 0 was at 0. Pi over 4 was at 1. And at pi over 2, I have this vertical asymptote. It's separating each of these little squiggles. Then at 3 pi over 4, it's at negative 1, then 0, then 1, and then another vertical asymptote. Negative 1, 0, 1, vertical asymptote. Negative 1, 0, 1, vertical asymptote. Negative 1, 0. Now, I looked at my calculator to get the behavior, and they're kind of like, shoot, they kind of remind me of cubics. But it's like a whole bunch of them. Okay, so this one kind of goes like that. Look at these little squiggles. Okay, so this one has something different going on about the domain. So we have these breaks in the graph. That's where the graph cannot exist. Now I want you to think about when we had those periodic functions and there were breaks in the graph and they repeated every so often. We've got that going on here too. So x cannot be those values that give us an error or a vertical asymptote. So x cannot be pi over 2 is the first one, and then it's repeating itself pi over 2 to 3 pi over 2. That's 1 pi difference. So it's repeating itself every pi. Now let's think about the range. Well, it's going from the bottom all the way to the top, so that's all real numbers, or negative infinity to infinity. That means I do not have an amplitude. Now, as far as the period, it's repeating itself after every one of these breaks, so the period is pi. I'm going to go to the front page and copy those over to the front page. So the domain was interesting because x could not be pi over 2 and then every pi after that. Range is negative infinity to infinity. The period on this one was pi, and the asymptotes occurred starting at pi over 2 and then every pi after that. The next one is cosecant, and let's just remind ourselves that's 1 over sine. So in my calculator, let's remember what sine was. So sine was 0.7071, and you're like, how in the world does she know this? I've done it enough. So let's think what's going to happen if I do the reciprocal, 1 over sine. What do you think is going to happen here? When sine was 0, what's going to be 1 over 0? So back into my calculator. I'm going to do a fraction, 1 over sine x. That's cosecant. That's the only way to get it in the calculator. I get an error. Why am I getting an error? Because 1 over 0 is undefined. What's happening at each of those undefined places? Each of those errors. What do you think is going to be happening on the graph? Let's press graph. Another vertical asymptote. So every time we have an error, we get a vertical asymptote. So there's a vertical asymptote right here at the beginning. Then I'm at 1.4, 1.4. And looking at the graph, it does this kind of parabola thing. And then I've got a vertical asymptote. Then it jumps to negative 1.4, negative 1, negative 1.4. Then a vertical asymptote. Then it switches back to positive. Then it goes back to negative. And so here are my little parabola thingies. Yep. 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 Now I'll show you also how I see this graph, the way kind of I think of it sometimes. If I draw sine started here and then went up here and then down here and down here. So every time sine crossed the x-axis, I get this vertical asymptote because 1 over 0 is undefined. The rest of it gets flipped because it's a reciprocal. So these little hills get flipped for cosecant. That's how I think of it, but you can always use the calculator or Desmos to look at the graphs yourself. All right, domain. So this one we have those vertical asymptotes, so it's everywhere except they start at 0 and they repeat every pi. Let's think about the range now. I have two little pieces. I have one's going up and one's going down. So if I start at the bottom, these graphs go to negative infinity up to negative 1. Then I have a gap and they go from 1 to infinity. So let me remind you how we would write that. It's negative infinity to negative 1 and then from 1 to infinity. Again, because these go all the way to infinity, we don't really have amplitude to talk about, so we don't have to worry about that. The period is kind of interesting because these vertical asymptotes aren't happening at the end of a full cycle. They're breaking up each of these pieces, and a full cycle would have a top one and a bottom one. So the full cycle goes between 0 and 2 pi, so my period would be 2 pi. Okay. So on the front page, we had asymptotes occurring starting at 0 and repeating every pi. We had a very strange range. It went from negative infinity to negative 1, and then from 1 to infinity. The period was 2 pi, and wherever these are my asymptotes, where x cannot be. So put that down. The next one we're going to do is secant. And I bet we're going to have something very similar, just kind of shifted because cosine is a little shifted. And so let's remember secant is 1 over cosine. So that's where I'm going to be looking at. Okay, so in the calculator, I already had it set up as a fraction. So I'll just change that to cosine and go look at the table. So 1.414, error. What do you think's happening at the errors? Those are going to be vertical asymptotes. We're going to have a very similar situation. But this time, my vertical asymptotes are happening every pi over 2. So, I mean, every, like 1 pi over 2, 3, then I bet it would happen again at 5 pi over 2, and then again at 7 pi over 2. And I have a feeling we're going to have those little swoops like we did with cosecant, and look at there. Some people say they look like teeth or something. I don't know. Rainbows. But regardless, we're going to have these little parabola-looking things repeated over and over and over. One going up, the next one going down. And the next one would go up. So this one's very similar to cosecant. Starting with the domain. Where do the asymptotes start? Well, they start at pi over 2. And they're not occurring the full period, but halfway through it. So happening every pi. The range is exactly like it was with cosecant. The period is 2 pi, because that's 1 full circle. Last one, cotangent. Now let's remember cotangent is 1 over tangent. Ooh. Did I ever type that in right? Why am I getting errors? Oh, look at that. Those errors happen every time I have an asymptote. But there's something wrong with the way my calculator is doing this because, whoa, the bell just rang. That's weird. Because it should go through 0 at certain places. So let me try typing that in again. Let me type it in a different way. What's another way to do 1 over tangent? Well, or cotangent. I could do cosine x over sine x. Let's see if that actually does it better. I'm not sure why my table was not doing well. That looks better. Error, then 1, 0, negative 1. Error, 1, 0, negative 1. Error. At each of those errors, we have a vertical asymptote. It's a vertical asymptote here. Then it goes 1, 0, negative 1. 1, 0, negative 1. 1, 0, negative 1. 1, 0, negative 1. And looking at the graph, it has like that same kind of cubic-ish look to it. Egyptian, yep, and yep. Again, in my domain, I have places that it doesn't exist. So x cannot be, starts at 0i. The range is infinity to infinity. The period. On this one, it does repeat every time we have a vertical asymptote, so the period here is pi. I'm going to copy those to the front page. And in the next video, we'll be talking about transformations of these. Some of the online assignments may already include transformations, so you may need to actually watch the next video too. I'm going to post videos from another teacher as well, just in case you want to see it a different way.